I hope you can see the slide. Yeah, yeah, okay. So if you have been there in the class, in the previous classes, so it is related to that only almost, Bosnia's theory. So first we'll go through the question. The vertical stress at point P1 due to the point load Q on the ground surface as shown in the figure is, this is actually sigma z. Okay, this is misprinted. This is sigma z. So if it is sigma z, if this is sigma z due to this is the stress. Okay, it can be in kPa or pascals, any stress units. This is in kilonewton or newton force units. According to the Bosnius equation, the vertical stress at point P2. So we have to find out based on this given data. Okay, if you know the formula for this increment in the stress due to this some load which is applied on the ground surface, then we can easily solve that. So we'll just reproduce the diagram. This is Q, somewhere at point 1. So at this point, this is sigma z and this is R. This is, sorry, I think this is R, this is Z, correct. This is R. Is this correct? Yeah. So, so what is the formula for increment in stress due to a load Q? According to Bosnius theory, this is 3q pi 3q by 2 pi z square 1 by 1 plus r by z square whole power 2.5. Okay, so let us uh, put these values r and z. See here, r means the horizontal distance from the line of application of the load. Z is the depth at which the point is there, vertical distance from the ground level. Okay, now if you put these values, you will be getting the same formula, because from the formula only they have taken these values and they have given here. So at point P1 sigma z will be the same formula. Just coincidentally it is equal to z is equal to z, r equal to r. So at P2 we will solve now. 3q 2 pi, z means depth. So what is the depth for P2? It is z by 2. Okay, so 1 by 1 plus, what is the horizontal distance from the line of application of the load? Here this is r by 2. Okay, in place of z you have to put z by 2, right? So whole power this. So this, so power square here, this will be cancelled. Then if you take this to next page, P sigma z at P2 is 3q by 2 pi z by 2 square into 1 by 1 plus r by 2 z by 2 square. So here these are cancelled. So this term will be again 1 by 1 plus r by z square whole power 5. There is no change in this term. Coming to this, you take this 4 above 2 square, then again 3q by 2 pi z square. So if you see that, it is equal to this formula again, which is equal to at the rate P1 other than this 4. 4 into, you can write sigma z at P1 or 2 at P1. Yeah, at P1. This is equal to sigma z at P1. So answer is 4 sigma z. So here answer is 4 sigma z d. So this is very simple, but this is of 2 marks. If you know the concept, it will be very simple. So moving on to the next question. This question is related to the pile foundations. Nikesh, can you hear me? I hope you can hear me. So the first problem, do you have any doubts? That is okay, right? Yeah. Yeah, fine. So moving on to the next question, this is regarding the pile foundations. I have recently explained what are pile foundations and what is the use of pile foundations, the classification and all. Uh, so here pile foundations are long, you can foundation height or depth will be uh, very much higher compared to the width or lateral dimension. So this lateral dimension can be sorry, this cross section can be square cross section, rectangular, or circular cross section. Suppose you can see a circle or you can see a square here. Okay. Now we'll read the question first. The ultimate load capacity of a 10-meter long concrete pile. The height is 10 meters. So you can say this height is or from the ground level. This is 10 meters of square cross section, 500 mm by 500 mm. This side of the square is 500 mm. Okay, zero point 0.5 meter. That is divided into homogeneous clay layer. This is homogeneous clay. Homogeneous means the shear strength is same at every point, at every depth. So that is called homogeneous clay. Having undrained cohesion value, you can write Cu. That Cu is 40 kPa. Okay. The ultimate load capacity is also given. That is 700. Okay. If the cross section of the pile is reduced to 250 by mm, 250 mm by 250 mm from 500 mm by 500 mm, the cross section is reduced as well as length is increased to 20 meter from 10 meter. So in that case, the ultimate load capacity will be how much? Okay, we just have to find out. So let us first note down the given data. Length of the pile L is 10 meter. The cross section of pile is square, and if you take it as, I'll just draw that. This is a little difficult. Okay, if the side is taken as b as it is square, so here b is given as, this is the case 1. Okay, this is case 1, 500 that means 0.5 meter. Okay, the length is, in the case 1, the length is 10 meter, b is 0.5 meter, and cu cohesion, underlying cohesion is 40 kPa, and the strength of this, the bearing capacity of this pile, if you denote it by q, in the compressive load, compressive capacity, that is given as 700 kilometer, right? Now, as we have discussed in the previous classes, the capacity of a pile, is due to two factors. One is end bearing, due to the end bearing plus, and frictional resistance. Okay, so now end bearing formula for the shallow foundations, I'll just draw here, just right here. For the shallow foundations, as we discussed, that is, this is small q in terms of kPa, the bearing capacity in terms of kPa or pascals. You can write CNC plus uh, anybody joined? Yeah, fine. So gamma effective, you can write gamma submerged. It can be gamma bulk also, if there is no water table. If there is water table, you have to consider gamma dash, depth of foundation into NQ plus of gamma dash b into n gamma. So this is the bearing capacity formula for end bearing resistance. Okay, for the shallow foundations. So in this, uh, if you go for the clays, this term will become zero because of this n gamma will become zero. This will be zero in case of clays. Okay, so, and if you go for the net capacity, this is the gross capacity, right? If you include this and this, that will become gross capacity. If you want to go for the net capacity, you have to go, this NQ is 1, NQ equal to 1 in case of clays, and this total term will become 0 in case of net, because you will deduct the same amount. So let us, first of all, let me discuss one shallow foundation that will be easier for you to understand. If this is DF, okay, this formula CNC plus gamma dash DF into NQ. Anyway, this is 0. I am not writing this. Okay, this is gross. Okay, so in case of net means, for this foundation to be constructed, what do? You will excavate this much soil. So let us say this much soil you will excavate. After that, you will construct this foundation. Now, after excavating, after constructing, if you pour the soil again, due to this soil, this strength will come, right? Due to this soil. Suppose if you want to have the net capacity, if you want to calculate the net capacity, what you have to do? you just have to deduct this capacity is coming due to the depth of the foundation. Okay, so if you want to calculate the net capacity, you have to deduct this portion by using just stress which is due to this weight. What is that? Gamma dash, which is equal to total height df. Don't think that the footing height is half of df and soil is only this much. This height of the footing is neglected when you calculate the stress due to the soil which is filled back. So then the soil which is filled back, the height of the soil will be again taken as df. So if you do, you have to deduct this much to get the net, because this is coming due to this. So in this case, in case of clays, we have discussed already nq equal to 1, gamma df minus gamma df, then it will become 0, this term. So finally you will be left with for bearing capacity of the shallow foundations, that is only c and c. C is cohesion and c is the bearing capacity factor. So here in case of pile foundations, you don't fill soil again, because this is not in the shape something like this where you can fill again, where you can fill the soil again after excavation. You cannot fill. So that is the reason why this you will have only net capacity. If you have only the net capacity, the end bearing formula will be C and C only. There will not be this term. Okay. Now, as it is undrained, you can take Cu. Then frictional resistance in the soil, due it will be happen. It will be uh, coming due to the cohesion. If C is the cohesion, the resistance offered by a clay particle will also be equal to the cohesion only. But if it is in between two clay particles which are rolling one over each other, then the frictional resistance is equal to C. But here we are talking about the frictional resistance in between the clay, surrounding clay, and the pile which is inserted. The frictional resistance in between that surrounding clay and this material, concrete material, it depends upon the addition factor. So you cannot get full cohesion as frictional resistance. It will be reduced by some amount. If you multiply that alpha with C, the alpha C will be the frictional resistance. So that's how you will get the alpha Cu. Okay. So this is the formula to find out the capacity of the file. Now Q equal to CUNC plus alpha Cu bar actually, because you have to take the average Cu value over the depth. Okay, over the depth. So anyway it is homogeneous clay, so you will have the same single Cu value everywhere. So now we have been given in the case 1, according to the given form given sorry, see this is small q. Anyway, to get uh, q in terms of kilonewton or newton, capital Q, you have to multiply the areas, bearing area multiplied by bearing resistance and surface area multiplied by frictional resistance. Okay, now what is bearing area here? In case 1, AB equal to B into B. Why B into B? Bearing resistance means it is at this point. Okay. So what is the area? B into B. It is square. So B into B. In the case 1, it is zero point 0.5 into zero point 0.5. So 0.25 meter square. And what is the AS? What is AS? This total length is 10 meter. How to calculate surface area of a cuboid? You just have to take the perimeter 4 into B into L length. That is the surface area. 4 into B is the perimeter, then length. So here 4 into 0.5 into length equal to 10 meters. So 40 into, can you calculate? Yeah, it's 20. Okay, 20 meter square. So you know AB, you know AS, and you know Q also. Q is also given in case 1. That is what? How much? I think it is 700 kilonewton, right? Yeah. And C value is given as 40 kPa. Can you substitute all these things in formula? See, NC value is always for pile foundations. It is generally taken as 9. Remember this. Okay. Now put all these values in this formula. 700 AB is 0.25 into Cu is 40 into 9, right? Plus AS will be 20, sorry, 20 into alpha, we don't know. And what about Cu? Cu is again, so, 20 into alpha into Cu bar. Cu bar is 40, right? So this is the form substitution. Then just rewrite that 700.25 into 40 into 9 plus 20 into alpha into 40. Okay, this is from the case 1, and from case 2 we will see one. So what is the case 2? In the case 2, this B value is reduced, L value is increased, nothing else, no change. So again, what shall we do? That Q equal to CNC into AB plus alpha into Cu bar into AS. Okay, AB is B square, AS is 4 into B into L, L2, and this is B2 because this is case 2. Again, C is 40, NC is 9, AB is B2 square. Here B2 square is how much? This is 0.25 into 0.25, right? 0.25 into 0.25, 0.25 square plus alpha, we don't know what is the value given. Cu is 40, right? In the previous case, and now Cu bar, that is AS4BL, 4 into uh, B is B. So B is how much here? Sorry, oh, I can tell you in case 1, L is 10, B is 0.5. Case 2, L is 20, B is 0.25, right? So now what happened in case 2? Suppose B2, L2, L1, B1. You can write L2 as 2L1, whereas B2 as B1 by 2. Do you agree this? Can you tell me whether I am right or not? Can I write like this? Can I write? Yeah. So, okay. Now, what do I do in this case? As I don't know the factor alpha, I'll just 40 into 9 into 0.25 square plus alpha as it is, Cu as it is, As in place of As 4BL1, 4B2L2. Okay, so 4 into 4B2L2. In place of B2, I'll write B1 by 2. In place of L2, I write 2L1. So These two will be cancelled, and alpha Cu again 4B1L1, right? This is nothing but this is Cu alpha. This has come from 4B1L1, right? This is equal to this. So as you don't know the alpha value, you can find out alpha value from this. Okay, and you can substitute that alpha here, or else you can just take from the case one. What can I write is, just a minute, from the case one formula I am writing again. 700 equal to 0.25 into 40 into 9. I'll just write this is QF. So QF, this whole as QF. Here also QF because both are same. Okay. Now what do I do? I'll find out this is case 1. I'll find out what is QF from this. Can you tell me what is this? How much is this? 610. This is 610 kilonewton, right? You know QF now. Now from the case 2, directly, what is the case 2? You have to find out Q in the case 2. You know this. You know anyway this QF is same as that of previous. So you just substitute this 40 in the case 2. Total Q is 40 into 9 into, here in this case 0.25 square, plus QF is QF 610. Okay. So how much is this? 40 into 9 into 0.25 square plus 610. Can you tell me? This is 632.5 kilonewton. So this is how you can find out the ultimate capacity for this case for 632.5. B is the answer. Is there any doubt in this? So I hope it is cleared. So in the next class, I'll be discussing about the vein shear test and problem related to that. So for this class, I have discussed two problems, right? So I think I'll be closing this session for today. So is there any doubt? So I'll be closing the session then. Next Thursday we'll be meeting. Is it fine? Yeah, okay. Okay then. See you later.